This video will guide you through using ZibraVDB with heterogeneous volumes in Unreal and how to achieve optimal visual quality and performance. Additionally, I will demonstrate how to resolve common path tracer issues when rendering volumetric effects. By default, ZibraVDB utilizes its proprietary volumetric renderer due to its superior speed. However, with noticeable performance improvements introduced in Unreal 5.6, heterogeneous volumes got a bit closer to real-time usage, but it requires a bunch of configurations to make it work as you need. To switch render on ZibraVDB to heterogeneous volumes, activate the Use Heterogeneous Volume checkbox on ZibraVDB actor. Upon activation, you will observe a degraded visual quality characterized by entirely black shadows and noticeable flickering. First, it is important to understand the shadowing mechanism in heterogeneous volumes. If your volume isn't casting any shadows, navigate to Project Settings and enable the Shadow Casting parameter within the Heterogeneous Volume sections. Now you can click on ZibraVDB actor, scroll down and toggle this Cast Shadow parameter. You may notice that when shadows are disabled, flickering disappears. That's because when shadows are enabled, the effect uses a low-resolution shadow map for self-shadowing. To resolve this, we can increase the shadow map resolution using next console variable r.HeterogeneousVolumes.shadows.resolutions and set it to 1024, for example. Now shadowing is more stable. Okay, now let's get rid of that black shadow color by enabling indirect lighting. For this, use next two console variables r.HeterogeneousVolumes.IndirectLighting and set it to 1, and the second r.HeterogeneousVolumes.IndirectLighting mode and set it to 2. Now black shadowing is gone, and we kinda got the opposite problem. Contrast is lost and the effect looks just flat. That is because it lacks ambient occlusion, and we can enable this too by setting the var r.HeterogeneousVolumes.AmbientOcclusion 1. Now it's way better. We got contrast back and a lot of details are now visible, but there is one main drawback with ambient occlusion. It affects performance a lot. It traces many rays in different directions to calculate ambient shadowing, causing a noticeable performance drop. We can reduce the number of ray casts by using next CVAR. r.HeterogeneousVolumes volumes, ambient occlusion, max step count, and set it to 24 all over. Now it still looks good, but it is much faster now. For ambient occlusion, you might also consider setting the max trace distance, which defines the maximum ray casting distance. Lower values for this variable can enhance performance. I'll use 300, which is 3 meters, but you should adjust this based on your effect size. That's all you need to know about using heterogeneous volumes with ZibraVDB in real time. Now let's see how this effect will look when rendered with path tracer. Just click here and select path tracing. First thing you will notice is that the effect looks much more dense in path tracer, so we need to reduce the density scale on ZibraVDB actor. And much better now. Depending on the size of your effect or the number of the effects in the scene, you may encounter different artifacts caused by video memory limits. You will see those artifacts if I just duplicate these effects. And there you go. To fix that, just use next CVAR. r.HeterogeneousVolumes volumes or the grid, max bottom level memory in megabytes, and let's set it to 512. This will increase the video memory limit for rendering, and artifacts should be gone. If that didn't help, try to increase another memory limit using a similar command. r.HeterogeneousVolumes First grid max bottom level memory in megabytes and set it to the same value of 512. In some rare cases where your effect is scaled, you might encounter some distance-dependent artifacts. You can use the next variable as a workaround. r.HeterogeneousVolumes, volumes, tessellation, far plane auto transition, and set it to 0 to disable it. And that's it. To ensure these changes are permanent, you need to add the vars to the configuration file, such as default engine.ini. You can find these and other console variables in the video description. Thank you and goodbye.